Hey, the assignment in Canvas said print these notes if you're able to print them. So go print them right now if you're able to. Okay. And also, I want you to try to answer every single question on these notes before you watch any more of this video. Seriously, I want you to try to answer them all. Well, with the exception, I suppose, of number 5. You can think about that if you find it to be an interesting problem. It's not one that I'm actually going to answer today, so we don't need to worry about it. But again, stop this video and try to answer every single question. It really will be a better learning experience for you if you do. So I'm gonna stop talking for 5 seconds, and then I'm going to talk through these notes. Okay, let's dive right in. What is the measure of angle ABD? Now, I trust that you have all learned about the names of angles. Sometime in middle school or even grade school, that angles have 3 letters in their names, and the middle letter is what we call the vertex of the angle. That's the bending point, the elbow, so to speak, of the angle, right? It's where the 2 sides of the angle come together, the vertex of the angle. So we're talking about this angle here that goes from A to B, turns at B, and then extends towards D. We're talking about that angle right there, which is 120 degrees. Okay. The vertex is point B. The 2 sides are A, B, and B, D. Right? Naming angles, it's very important that you understand how to name angles and the difference between naming angles and naming segments. We talked about naming segments, in the last unit. Sometimes I'll ask students a question, and what I'm expecting is maybe a segment name or an angle name, and they'll write to me something like this. And they will not put a segment bar above it, and they will not put an angle symbol in front of it. And then I don't know what they mean. I truly, truly don't know what they mean if they just write this down without an angle symbol in front like this or a segment bar above like that. You have to include the symbol, okay, either the angle symbol or the segment bar, to make it clear what you are talking about, okay? And if in this diagram somebody wrote ABD and put a segment bar above it, that would be worse than that would actually be worse than no segment bar at all, because now they're talking about what seems like a straight segment, and yet from A to B to D is not a straight line. So I really don't know what they mean by this. Okay, you could, if you put an angle symbol in front of it, now that makes sense. If you're talking about, let's say, the straight segment that goes from point A to point D, and we can talk about that segment even though it isn't drawn in the picture, we could talk about segment AD. As long as point A exists and point D exists in our study of mathematics, then we say that we know where segment AD is, and we can talk about it and think about it even though we haven't actually drawn it. Okay, so you've got to include your segment bars, you've got to include your angle symbols when you name things. All right. I believe you've also learned about acute, right, and obtuse angles, that right angles are 90 degrees exactly, obtuse angles are larger than 90, and acute angles are less than 90. Now, here's another name for the same exact angle. Angle symbol DBA. All right. B is still the vertex, but it does not matter whether the A comes first and the D last, or the D comes first and the A last. Just as we can turn around the letters in the order of a segment name, it really makes absolutely no difference at all what order the letters come in a segment name. But there should only ever be 2, right? And there should be 3 letters in the name of an angle. Okay. What is the measure of angle BDE? Probably most of you recognize that symbol as indicating that that is a right angle whose measure is 90 degrees. The vertex is D. The 2 sides are BD and DE. And another name for this angle EDB is what I'm looking for. Okay. The measure of angle DEC. All right. You need to learn something now. Stop. Just stop. Don't race through this part of the video. This is going to surprise all of you. What is the measure of angle DEC according to this diagram? I'm going to write CBD, which is my abbreviation for cannot be determined. This picture does not tell us how many degrees this angle is, like it tells us how many degrees this angle is, and it tells us how many degrees this angle is. I know this angle looks to you like a right angle. I drew it so that it would look like a right angle. I agree with you, it looks like one, but looks like it is almost never enough evidence to come to a firm conclusion about something in this high school geometry class. I'm going to say that again. It looks like it is almost never a good enough reason for an answer. Okay? This looks like a right angle, but there's no right angle marked. There's no 90 degrees written inside. You cannot say, you're not allowed to tell me what the size of this angle is. Anything you give me other than an answer like this will be marked wrong. Okay? We are not allowed to assume in high school geometry that angles that look like right angles truly are known to be right angles. So there is no answer to this question. All right? This angle size cannot be determined. How about the measure of angle ACE? Well, also, that cannot be determined because there's no number in there. Okay. Is it acute, right, or obtuse? Now, this one may surprise you even more. It sure looks like it's an obtuse angle. Okay. But again, in geometry, we should not even assume that angles that appear to be obtuse truly are obtuse, or that angles that appear to be acute, which is less than 90 degrees, truly are acute, any more than we should assume that angles that appear to be right angles really are right angles. Okay. Here's what we are allowed to assume in geometry, and this may seem a little crazy to you, but we are allowed to assume that lines that are drawn to appear straight truly are straight. Okay? We are allowed to assume that. So in this diagram down here, we are allowed to assume that from F to H to L is a perfectly straight line because it sure looks like a perfectly straight line. All of these lines look like straight lines, and we are allowed to assume that they are, in fact, straight lines. But again, I say this again because I always find that I have to. We are not allowed to assume that angles that look like right angles really are right angles. And I said a moment ago, this might seem crazy to you. It might just seem crazy to you that we're not allowed to assume that right angles that look like right angles really are. And that might seem crazy just because you always did assume that. But it might seem even crazier to learn from me that we are allowed to assume that lines that look straight really are straight, but we're not allowed to assume that angles that look like right angles really are right angles. Why are we allowed to assume one thing and not the other thing? Well, there is a decent answer to that question, but I just don't want to take the time to go over it in this video. I'll save it for another day. For now, you just have to learn what you're allowed to assume and what you are not. Okay? All right. What is the measure of angle N? Surprise! This is a bad question. And that's the best answer to this question, that it's a bad question. Okay. My guess is that many of you answered 97 degrees by adding up the 45 degrees here and the 52 degrees here. Here's the problem with this question. If you ask me this question, angle N, how do I know whether you're talking about angle HNL, which has N as its vertex? That would be this 45-degree angle from H to N to L. Or maybe you're talking about angle FNH, because that has N as its vertex. But that would be this 52-degree angle over here. Or maybe you're talking about angle FNL. Is that the angle you're talking about? Because that has N as its vertex, and that would be 97 degrees. Like, how do I know? And some of you might be thinking, well, shouldn't it be like the whole angle N? I mean, shouldn't you just assume that? And the answer is no. No, I shouldn't just assume that. Let me give you this picture here. Watch this. Okay? Let's put a little point right there, and let's call that point V. And I'm going to put points around here and call them A, B, C, D, E, and F. Okay? And if I asked you, what is the measure of angle V? And I put numbers in here. Let's make this 30. Let's make this 100. Let's make this 50. Let's also make that 30 and 100 and make that 50. What angle size would you tell me? For angle, am I talking about CVD, DVE, EVF? Am I talking about EVC? Am I talking about AV? There's so many different possibilities. And in your mind, if you're thinking, well, just the whole angle V, like, what would you even be talking about? What? The whole, what do you mean the whole, like all the way around point V, 360 degrees? Are there such things as 360-degree angles? I mean, we can talk about rotating 360 degrees. If you ride a skateboard, you can do a 360, which means you spin completely around in a circle. But in geometry, it doesn't even really make sense to talk about angles that are any larger than 180 degrees. I don't know what answer you could, you could give me lots of different answers if I asked you this question. That's the problem. Okay? Now, you can get away with a single letter name for an angle if there is no confusion, no uncertainty at all about what angle you're talking about. And this can become a little confusing for students. Let's go back to this picture up here. What is another name for angle DBA? You could give this name, angle B. That is an acceptable name for this angle in this diagram because there's only one angle at point B in this diagram. Nobody could be confused about which angle I'm talking about if I say angle B in this diagram. All right? But if I have another diagram, a different diagram, and I've got a point B there, and I have an X and a Y and a Z and a W there. Now, if I say, what is angle B's measure? Well, that's confusing. There's lots of different angles whose vertex is point B. So sometimes you can get away with a single letter name when it's absolutely clear in the picture what you are referring to. But in a diagram like this, a single letter name for angle N is a totally bad name. Okay? And I won't ask you a question like that and expect you to tell me, hey, that's a bad question. I will be very clear about the angle measures that I'm asking for, like in part B. All right? And so what's the measure of angle FNH? It's 52 degrees, and that's an acute angle. LNF, LNF, that's this whole angle here. That's 97 degrees. That's an obtuse angle. All possible names for the angle whose measure is 85 degrees. That's this angle right here. You could call that angle FHN, from F to H to N. There's that 85-degree angle. Or you could call it angle NHF. Turn the letters around, keep H in the middle. But you cannot, absolutely not, call it angle H. Okay? Because you could, sorry, I not really seeing all of that. You can't call it angle H because there are two completely different angles at point H. In fact, there are three completely different angles. There's this 85-degree angle, this 95-degree angle, and then this angle, which is a straight line, but you can think of it as an angle of 180 degrees. So this is not a good name for that 85-degree angle. The 40-degree angle over here, well, I could call it HLN, or I could call it NLH. Okay, those are two good three-letter names for that angle. I could also just call it angle L. I could get away with that for this picture. Okay, but hey, there are still two other good names for this angle, this 40-degree angle. Did you get more than these three? How about FLN? FLN. That's a good name for this 40-degree angle. That's as good as HLN. All right. Really no difference in these two angles. These two angle names are different, but they're really identifying the same exact angle in this diagram. And of course, I could turn those letters around and call it angle NLF. Okay. All right, let's go to the back side. Based on your visual judgment, which is something that we are not going to trust very often in this course. You hear me? I'm going to say that again. You're not going to trust our visual judgment very often. There will be occasions where I will encourage you to use your visual judgment to think through a problem, but not very often, not for a while. Okay? I am asking you to use it on this problem. And in this problem, I think most of you probably had very little difficulty deciding that 25 degrees should probably go there, 100 degrees should probably go there, and 55 degrees should probably go there. Okay? What do these marks in this diagram mean? Well, it means that this angle here, angle G, because it has an identical mark to angle H over there, they are congruent. And oh, you know what? That reminds me, I don't know if I talked much about this symbol or that word in the last unit, and I should have. This is an equal symbol with a squiggly over it. And that means is congruent to, and you're probably all familiar with that word, congruence or congruent. And it means has the same measure, is having the same measure as something else. Okay. It's so much like the word equals. You sometimes wonder why we need a special symbol and a different word. Okay. And again, there is a good reason for that, which I'm not going to go into today. But we do use the word congruent in geometry, or the symbol congruent, not the symbol equals. That's for algebra work. Okay. Congruence is what we use in geometry. This diagram also tells us that angle F is congruent to angle I because they have identical marks in them. Okay. Now here's what the marks don't tell us. They don't tell us that this angle is larger than this one. I know this arc has more marks in it. It has two marks in it, and this one only has one in it. But the number of marks is not telling us how the sizes of these angles compare to each other. Okay. And that's just a fact. That's just the way it is, and you need to learn that. Okay. Don't be fooled. We are not allowed to judge from this picture that this angle is an obtuse angle. I know it looks like an obtuse angle. I know this looks like an acute angle, but we're really not allowed to make those judgments. And the marks don't help us. They don't tell us that this angle is twice the size of this one because it has twice as many marks, or even any bigger at all than this one. Okay, that's not what the marks tell us. Okay? They only tell us that these two angles are the same size as each other And these two angles are the same size as each other. Okay? I think you're going to find the homework assignment will go by very quickly, and it's going to feel very easy. But there are many places in the homework assignment where I'm ordering you to stop and check your answers. Please do that, because I want you to catch yourself making any mistakes early, if you make any, so that you don't repeatedly make those mistakes over and over again in the homework. Because if you make the same kind of mistake repeatedly over and over again, what happens in your brain is you get really, really good at making that mistake. And then you're going to make it again in the future on a quiz or a test. So when the homework assignment says stop and check your answers so far, please do that. Okay. And if you got anything wrong, try to make sense out of what you got wrong before you go on to the next set of problems. Okay. I think that's all I've got. Yeah, the homework assignment should go quickly. It should feel very easy, but getting answers quickly and easily doesn't mean you're getting the right answers. So check them as you go. Email me or reach out to me with any questions. Okay, we're done.